The final section of this course focuses on dimensionality reduction techniques. I start with a discussion of what dimensionality reduction is used for. Then I show the first dimensionality reduction technique, principal component analysis. Then I talk about singular value decomposition, a linear algebra decomposition of great importance. Finally, I discuss multidimensional scaling. Now let's start talking about what we're doing with dimensionality reduction. In this video, I introduce dimensionality reduction techniques as an unsupervised learning method and discuss what the objectives of dimensionality reduction are and what it is used for. Dimensionality reduction is considered an unsupervised learning method since there is no target variable we are trying to predict. The other unsupervised learning method we saw was clustering, which was unsupervised learning's analogy to classification. Dimensionality reduction is the unsupervised learning analog to regression. We are trying to discover features, often in Euclidean space, that we do not directly observe in the data, yet we believe influence patterns seen in it. Perhaps you may recall the curse of dimensionality. This is a phenomenon where distances in higher dimensions tend to be large. This makes learning difficult since every data point tends to be far away from other data points. However, the problem could be exaggerated. The data may actually be described well by a space of much lower dimensionality. For example, I've illustrated data here that looks like it's in two-dimensional space, but a one-dimensional space, a line, describes the data fairly well. There will be some error resulting from this representation, but this error should be small. The objective of dimensionality reduction is to discover this low-dimensional space. Dimensionality reduction techniques have a number of uses. Perhaps the most immediate use is visualization. High-dimensional data can be visualized in two-dimensional space, which humans can understand well, allowing for spotting patterns. We could be using dimensionality reduction for creating features. This could be simplifying features or generating new features entirely when none existed before. With dimensionality reduction, we could be trying to simplify a dataset. There could be many features, but we can use dimensionality reduction to narrow the features down to just a few that can be used for supervised learning. Another use is compression. We might develop a feature set that recreates the original dataset with minimal error. We will see just about every one of these uses in upcoming videos.